Us.
You.
And me. We listen to you.
Our city.
Wake up, citizen. We are a part of the whole thing.
Evolving.
Evolve.
Our roots and visions build our tomorrow. We walk
Together our common path.
I move with you.
We grow up and learn.
Ahead.
It's possible.
It is. It will.
We love.
We care.
Improving day by day.
What can we do for you?
Why do you like me?
Why do we like you?
Breathing the same air.
We share and experiment. We move and change.
We can do so many things.
Let's talk.
Let's create.
Let's innovate.
We can do it.
Together.
You make me feel alive.
We want to make our dreams come true.
Have a co-creative day.
It's a brand new day.
New day.
Bon dia a tothom. So good morning to everybody. Today we have a talk about the social aspect of big data. We put more and more things, more and more routines, more and more procedures in software. This social aspect is more and more important. And today we have Susan Etlinger, that is an expert, a very well-recognized expert. Just look at the TED Talk, that she has, that will go and will walk us through this social aspect and so on. If you want to know more about her, the last study is the trust imperative, and I think you will enjoy it. One more thing, remember that we have questions after, and then remember to use this Ask and Vote app just to put all your questions. We will gather the questions, and then we will ask to Susan. Thank you so much. Susan.
Good morning, everyone. Buenos dias. I hope everyone's feeling good. I know I am. I'm really, really honored to be here today to talk about artificial intelligence. I have been studying this for quite some time, and I'm sure all of you are probably at various levels of thinking about this. And so before we start, I'd like to start with a definition. And I will tell you that in the research I've done, there are many, many definitions of artificial intelligence. Some are terrible, some are actually quite good. They're all interesting. Fundamentally, though, I think artificial intelligence involves the ability for computers to learn, to reason, and to interact. And so one of the things about discovering what artificial intelligence is thinking about what intelligence is at all. It's almost sort of an arrogant thing to say that we actually understand what human intelligence is. But if we go back to 1983, even before the internet, there was a psychologist, a developmental psychologist by the name of Howard Gardner. And he developed a theory of 9 types of human intelligence. And I think that this gives us a very good model to start to think about the ways in which machines can simulate human intelligence. And so you can see from this list, there's naturalist intelligence, our understanding of the physical world, musical intelligence, existential intelligence, the ability to ask why and understand why we live on the earth and what our purpose is. Interpersonal intelligence, cognitive, language, and mathematical intelligence. And so you can see that this is a way to start to break down what humans do into categories, but also potentially a way to break down what computers can do. So let's think about what artificial intelligence can do. I think the first thing we can agree on is that this logical mathematical intelligence is the thing that computers can do much, much better than we can, in the sense that computers can process incredible amounts of data very, very quickly. And while many of us, I'm sure in the room, are brilliant people, you know, a lot of times it requires a computer to understand everything. So if you think of a doctor, for example, who is prescribing medication for a patient, that doctor may be brilliant at what he or she does, but the chances that they've read every single medical journal ever written in every language on the planet throughout history is very, very low. So then let's look at some other kinds of intelligence. Musical intelligence, which is the ability to understand sounds. Body and kinesthetic intelligence, that's the ability to understand how to move. That's what athletes do, right? Linguistic intelligence, the ability to understand language, to listen selectively, to understand language, to translate language. And then finally, spatial intelligence, the ability to sort of move in the world. And so there is, you know, if you think about it, there are sort of three kind of main categories here, breaking it down into the simplest discussion. The ability to see, so for example, to take in images and interpret them. We see that with, for example, MRI scans. We see that with self-driving cars. The ability to communicate, to speak, to listen. The ability to gesture and move. And then underlying all of this is the ability to learn and reason. And so without learning and reasoning, what we have is processing, but not intelligence. And so, you know, there's a lot that artificial intelligence can't do today because it's still very new. But there's one kind of fun thing that I wanted to show you. And if you could play the, or just listen to this for a second. Okay, so this is the very first song ever written by artificial intelligence in the style of the Beatles. Now, you may think it's cute, you may think it's terrible. I will assure you that the longer you listen to it, the weirder it gets. So we're starting to see, of course, if you walk out here, you can see many, many examples of how people are building applications to start to understand what AI really means. You guys can turn the song off, thank you, if you don't mind. So let me go on to the next slide. And I want to give you kind of a brief history, because while we've been really talking about and hearing about AI in the past several years, it actually has quite a long history. So from 1950, when Alan Turing actually coined the term, or actually published a paper on machine intelligence and started to think about the ways in which machines could actually express human intelligence to 1956, which is when the term was actually coined. And if you look at this timeline, you can see various milestones along the way, and a lot of periods of sort of winter when the development kind of came to a standstill for various reasons. And so then if you look at the last few years, you see a few different things happening and some spikes really in interest, including when Cambridge University opened its Center for the Study of Existential Risk. Just think about that for a second, which they also called the Terminator AI Research Center, for any of you who have seen Terminator. So you can imagine, any of you who watch these movies or remember Blade Runner or watch Black Mirror or any of the many, many films and artworks really that have been written and built around AI. It's obviously on everybody's minds. And then of course we have Google's Deepmind in the last couple of years. Now, of course, where interest goes, money goes too, and so the investment in AI has more than tripled in the last few years. And so if you look at this next slide, you can see all the companies that are starting to acquire and that have acquired AI, and actually this starts to get to be completely unreadable given the pace of merger and acquisition activity. There are a lot of familiar names here: Google, obviously, Microsoft, Salesforce, Apple, The list goes on, and I think there probably isn't a single company or organization out there that hasn't touched artificial intelligence in one way or another. And so that's kind of where we are now. There's a lot of interest, there's a lot of investment, and it's still very new. So let's talk a little bit about why. In the past, if this term was coined in 1956, if people have been thinking about the ability to enable machines with cognition, why is it now in 2015 and 2016 and 2017 that we're actually seeing all of this development and all of this investment? Well, 3 reasons. I would like to credit Kevin Kelly, who is a writer and author, for kind of coming up with this nice, crisp little list. But you will see this probably in more or less anything you read about the subject. There are really 3 things that have happened. Number 1, big data. The amount of data and the availability of massive amounts of data. Much of this has been driven by the Internet of Things, of course, so the ability of the prevalence of sensors. Much of it has been driven by the social web, the availability of video, of sharing images, sharing video, sharing content, and of course other things on the internet and other market forces. Incredible advances in parallel computing, so all the data in the world doesn't matter if you can't actually process it. And then the third is the improvement in the algorithms. And the algorithms have become much, much better at hitting their objectives. Sometimes those objectives are really helpful, and then we also see that sometimes those algorithms can do things that we don't necessarily want them to do or hadn't envisioned that we want them to do. And so I want to talk a little bit now about, given all of this, given where we are, what can artificial intelligence actually do? Well, let's go back to this model. So we have the ability to see, to visualize images, the ability to move, the ability to communicate. Moving, of course, you think of robotics. Communicating, you think of other things. So I'm going to go through a few examples. The first is image recognition. So in order for AI to be able to recognize images, it needs to be able to see them, and it needs to be able to classify them. And then it needs to be able to learn from them. This is the important thing, and infer some kind of meaning. So to put it in much more concrete terms, let's look at this little boy. So all of you look at this photo right now, and you immediately understand what you see. It's a little boy, he's wearing a green jacket, he's standing outside, he's holding binoculars, he has a little bit of a smile on his face. It's a bit of a foggy day. He's somewhere, surrounded by forest. Well, here's what computers have to do. They have to use what's known as deep learning to go through sort of pixel by pixel, and imagine that, going through pixel by pixel to start to resolve the meaning of what these various images that we see so easily might be. And so the kinds of things that computers can see include objects. So that would be a person, a jacket, a hat, binoculars, trees, cars, people, etc. The next is scenes. So imagine outdoors, a football game, a wedding, a political rally, any kind of scene, a conference such as this one. The next would be attributes, so that describe the image. So the colors, the shapes, the weather. Another attribute might be, for example, what we call in the United States NSFW content. That stands for not safe for work. And that means content that might be either extremely violent or overly sexual or something like that. So attributes about the photo. And then finally, emotion detection. And we've seen, in fact, I think today Facebook made an acquisition of an emotion detection company. Apple has already done it as well. One of the things about emotion detection that's really interesting is that clearly it has tremendous privacy implications. But another thing that's really interesting about emotion detection is that from the stories that I've heard, the kinds of organizations who want to understand emotion detection are sports teams, for example, who want to understand whether an audience in a stadium looks more excited at one game than another, or whether maybe excitement is dropping off. They want to understand the mood. This would also be something in cities in terms of public safety that could be used for positive purposes or negative purposes to understand the mood of a particular population. So you can see how this has multiple implications. Now, just to give you a kind of a simple understanding of how this works, on the top we have a set of backpacks, and on the bottom we have a set of beagles. And you can see, you probably can't read the numbers, but there are tiny little numbers here. Those little numbers at the bottom represent the confidence level of the system to understand, to say, with this level of confidence, 0.99872, this is probably a backpack. You can imagine that as things are harder to understand, that those numbers would drop down significantly. But this is a system that has been trained to understand what backpacks look like. And then on the bottom, we have beagles. And when you think about this idea of training a set of data to understand and recognize what a backpack might be, it seems so simple, but it's actually quite complex because it has to look at the attributes of the backpack, and it has to figure out what's important and what isn't important. Now, in backpacks, one of the things that you might notice right away is that it doesn't matter what color they are. So color is not an important attribute for backpacks, and that's something that the system has to learn. With beagles, color is very important and actually can determine whether a dog is a beagle or another kind of dog or a mutt. And so this training data can be extremely important when you're looking at the ability of artificial intelligence to correctly identify the contents of images. So let me give you an example. Here's a photograph of 16 bagels. At least most computer systems would think that this is 16 bagels, but some of the bagels have tails, and they have noses, and they have cute little eyes. I actually ran this photograph. This is a meme that had been going around. I don't know if it got here, but it had been going around in the US over the past year. There were also, let's see, I think sloths and blueberry muffins and things like that. Anyway, so I ran this through an AI system. I didn't have time to show you everything, but it pretty much got it wrong right off the bat. The reason it got it wrong and thought all of these images were of bagels was because it had not been trained properly. Now, this can be funny and cute, the way that this photograph is, or it can be very disturbing. So last year, Flickr got into trouble because they have been automatically tagging their images. What that means is when somebody like us, we upload an image to Flickr and maybe we put 3 or 4 tags on it, but we can't think of all of the ways that other people might want to find our photos. And so Flickr will add tags. Now, they had a photograph of a field with a gate in front of it and a building in the background. And that was tagged sports facility, and it was tagged jungle gym, like you'd find on a child's playground. And in fact, that photo was of the entrance to Dachau, the concentration camp in Germany. And so this was, of course, very upsetting. And there have been many other examples of computer vision going wrong. So let's talk a little bit now about virtual personal assistants, another example. So imagine Siri, Alexa, Amazon's Alexa. They have to do something that's really complicated. Now, in Alexa's case, do any of you in the audience own an Alexa, an Echo? Okay, so any of you who own it know that you have to say, "Hey Alexa," for the Alexa personal assistant to respond to you. That means they're listening to everything you say, and they're only paying attention when you say, "Hey Alexa." Okay, so that's interesting. So you have to enable selective listening. And then they have to detect what language you're speaking, they have to translate that, and then they have to communicate back to you in some relevant way, and then they have to learn from what you do to understand what you might want to do the next time. So let me give you a little example. I thought I would ask Siri, because I have an iPhone, I thought I would ask Siri what artificial intelligence is. So I said, Siri, what's artificial intelligence? Siri says, okay, check it out, and gives me a definition from Wikipedia. So, like many of you, I don't necessarily consider Wikipedia to be the source of ultimate truth. So I say, Siri, do you have a better source than Wikipedia for artificial intelligence? And Siri says, I can't seem to find anything about that on Wikipedia. So, needless to say, not happy. And then this last little image is of a tote bag that was given out at an AI conference in the US a little while ago. And if you can't read it, it says, what do we want? It was about chatbots, okay, which are the ones that live in an app and not in a physical device. What do we want? Chatbots. When do we want them? Sorry, I didn't understand your question. So in some ways, this type of technology is very, very new, but it has some intriguing possibilities. Now let's talk about virtual medicine, because that's another application of seeing and of communicating. And you can see as we start to fill this in where we're going. So virtual radiology is a new application in medicine of artificial intelligence. And the idea here is that many hospitals no longer have or don't have budget to have a radiologist on site every single day. And every so often, unfortunately, someone will be injured so badly that they will have an intracranial hemorrhage, a brain bleed. Some of these brain bleeds are emergent, meaning that this person is going to die within minutes if they are not treated properly. And so triage is critically important. And if you don't have radiologists on staff, or much more common, right, your radiologist doesn't see this many emergent examples of an intracranial hemorrhage, then you can be in real trouble. And so this is a company that actually scans thousands of MRIs to determine the most critical cases and recommend a course of treatment. This is a way to offload some of the complexity of interpreting these MRI exams or CAT scans to be able to give the right answer back, and in many cases, save a life. Because the average neurologist working in a hospital, at least in the US, I don't know if this is true here, maybe only sees this kind of really critical case every 3 months or so. And as you all know, if you have a medical condition, you want to go to somebody who does it all the time. And in some of these rare situations, that's not possible. So, when we fill this in now and we get to gesturing and moving, and we add all of these things together, you can start to see the complexity of what self-driving cars have been able to accomplish, because they need to do all of these things, and they need to do all of these things in communication with other cars and with the road. So they are taking in information, they're comparing it against past information, they're calculating probabilities, they're moving the physical car, or involved in making decisions that affect the movement of the car, and that happens using essentially every single faculty that artificial intelligence has today. And so, just in a naked effort to appeal to you, I put up this story about the first self-driving truck mission. This was a 120-mile, just so you understand the incredible gravity of this technology, a 120-mile beer run. So they sent a self-driving truck on a 120-mile beer run. This is not like, when we put the first man on the moon. You don't have the same sense of wonder, but it is a pretty incredible accomplishment. So let's talk a little bit about cities and how cities might incorporate this technology, even in its sort of infancy, the way I mentioned today. The question I'd like to ask you is, what will happen, what becomes possible when cities can learn and reason? Well, there are lots of different things, and I'm not going to explain them because all you have to do is walk out these doors and see hundreds of examples. But two main categories here. In terms of infrastructure, which of course is highly optimized in cities already, and so maybe there are fewer opportunities to add, for artificial intelligence to add something over and above what already exists, but also in systems and services. And so let's talk about these in a little bit of detail. And these are promises, okay, or these are sort of hypotheses. This is not necessarily yet reality, but the kinds of stories you hear. Buildings could become more healthy, meaning that the air quality could be better, that there could be predictive technology applied to change the way that buildings operate, more energy efficient. Roads could send signals when they need repair. Energy sources could self-optimize. You know, all of these things, all of these examples include some level of learning. And you know, one of the things that sometimes people will say is, and when we have self-driving cars and cars are a service, we don't need garages, and then we can build parks. Now, whether or not this is true, I can't tell you, but it is part of the promise. Now, in terms of systems and services, I do want to mention a couple of things. One of the things that I think is really interesting is this idea that for the disabled and for the elderly, the ability to provide certain kinds of services, including, for example, self-driving cars, could be very freeing and actually very helpful to people who would not otherwise be able to move around on their own. The other thing I think is really interesting is a talk I heard from a woman at Carnegie Mellon University who is blind, who built an augmented reality system that actually talks her through, you know, the way that when you go to a museum and you get the little headphone and it tells you what you're seeing, that talks her through the city. So she still needs a cane to navigate the physical environment, but it tells her, walk 22 steps, turn right, and there's a grocery store where you can buy milk or whatever it might be. So that becomes really interesting, not only for the disabled and elderly, perhaps, but also for the tourism industry, because not all of us speak every language on the planet. Now, the risks, of course, are very clear. There are many risks to intelligent cities, and I would say that the risks are very city and country dependent. And so depending on the particular history of your city, of your town, of your country, there are different types of risks. Some of them are related to profiling and bias. The United States right now is experimenting with something called predictive policing, which can have very, very disturbing implications for profiling certain communities, particularly now after the election. I had to think about it, right? Data proliferation can put very vulnerable populations at risk. This is obvious. Cultures of surveillance, not new to artificial intelligence, but when artificial intelligence starts to learn from this data and make inferences based on the data, that's when you need to start thinking about what does this mean for society. One thing I really want to call out here is the gap between the data rich and the data poor. Some of these data sets are open and available. Some of them cost money to buy. And imagine an economy or a world in which you can't afford the data that gives you the answers that you need. So that's something to think about. Job loss, obviously. And then finally, what's efficient versus what's right? And that's something that all of us as humans are going to have to decide. So I want to end on a little bit of a call to action, and that feels particularly important right now to me. One is that I think that we need to be very clear about the accountability that we have with systems that can learn from us and from the world around them, which means that we need new methodologies and we need new guidelines to ensure ethical and efficient use of data. The next thing is that we need diversity. We need people from multiple avenues to be working on these problems together. And that could mean different utilities working together. It means working with non-government organizations. It means looking at the work of academia. Academics are working on some really interesting issues around algorithmic transparency. We need to be extremely clear about the way that we're using data. This is, of course, much more highly regulated in Europe than in the US. And we need to focus on job creation. This is not my area of expertise, but clearly we're going to be displacing jobs. And then finally, as I said, the collaboration piece. Here is a set of principles for ethical data use that was developed by the Information Accountability Foundation in the US. That's IAF.org. And it really has to do with big data, but I think, if you take a look at this, and this is part of the Trust Imperative report that was mentioned, you can see that these philosophies or these principles are really important to think about as we take data and we begin to learn from it. Because the truth is that our history is being written in data, and the decisions that are being made with data are going to shape our cities for years to come. Thank you.
Thank you so much, Susan. That's really nice presentation.
Thank you.
We have a few questions. Let me start with one question that has been pretty interesting and pretty well debated. It's algorithmic transparency. A few years ago, other people, like 5 years, said that government should have the right to look into the algorithms because so many things are there.
Right.
And without having this capacity, you just cannot enforce equality, fair treatment, and so on. And this has been very controversial. But now it's getting mainstream. I mean, Angela Merkel the other day in the European Commission said, well, we have to do algorithmic transparency, and we have to begin to start into doing these things. What do you think about that?
I am a huge believer in algorithmic transparency, and I think there's a challenge with it, though. The challenge is called business. And I work in business. I'm not an expert in cities at all. My focus really is on the business world. And when you're looking at profit-driven organizations require competitive advantage. Competitive advantage requires secrecy. When you're looking at countries at war, they're not going to be communicating their algorithms to their opponents. And so so this is extremely complex, and I'm not sure that I have the most perfect answer in the world, but I will say that when we are using data for the benefit of society, or for that there must be, first of all, mutual benefit between organizations and individuals, and that we have to be as transparent as is reasonably possible in order to be able to go back and understand what happened. Because if we allow machines to make these decisions for us, and we don't know why they did what they did, I can't imagine what history will look like.
Oh, wonderful. Well, time is up. Maybe we have one second for one more question.
Sure.
It's improving so much. AI, it's everywhere. What do you think the most salient areas or the most interesting in terms of social impact?
In terms of social impact. I think I love this example of the augmented reality. Now, this requires a lot of development and a lot of money and everything else. But I love the idea of looking at vulnerable populations and finding ways of using AI to help them. So, for example, there's a gentleman named Patrick Meyer. He uses drone technology, powered by AI, to deliver medicines to earthquake-stricken areas, for example, in Nepal, that are completely impassable, or actually after the hurricane, that are completely impassable. Services for the blind, services for other populations who might not have access to either medication or to education or to doctor services and that sort of thing. So I really think, if we're going to look at some of these social problems, that the technology can really help there. And I think that that's a good place to look because it will teach us a lot about what people really need.
Thank you so much.
Thank you all. My pleasure.